on how to do word problems. And basically what you're going to do is every time you come to a number, you're going to simply write down what that number means. Like, does it mean time, distance, velocity, accelerations, so forth. And what you do is you sort of look at the number and the units behind the number. So let's look at number 1. It says a student runs 40 yards. Well, 40 yards is a measure of distance. So what I'm going to do is I'm going to put D right above that 40, or off to the side here, you can simply write down what it means. So I'm going to write down that D equals 40 yards. Then it says in 6 seconds. Well, 6 seconds is a measure of time. Sorry about that. So I'm going to put down that T equals 6 seconds. This is pathetic handwriting. I might do it on the smartboard here. So it says, what is his average velocity? Well, pay attention to words like what, how many, when, that sort of stuff like that, because that tells you what you're trying to find or what it's asking for. So I'm asked for defined velocity. So I'm simply going to write down the formula, V equals distance divided by time. And so I take the 40 yards, divided by the 6 seconds. And that ends up giving me 6.67. I'm not using significant figures here. I should, but anyway. And it's going to be yards per second. Now on the next one, we're going to do the same thing. It says if I have a car, the car averages 60 miles per hour. Well, let's look at 60 miles per hour here. 60 miles per hour is my velocity. I said 60, it should be 65 miles per hour. I'll write that down. On a trip, how far? Well, once again, pay attention to these words like how. How far is means they want to know my distance. Will it travel in 5 hours? Well, 5 hours is going to be my time. So I'm going to use that same formula, but you can move it around a little bit. And I have this little trick way called the Wright triangle of knowledge, Wright meaning W-R-I-G-H-T. And so I'm just going to take a triangle, and I'm going to write the formula in that triangle. So the formula I'm going to write down here is V equals D over T. Well, go ahead and cover up the V with your finger, and you'll notice that it tells you the formula for velocity is distance over time. So whatever you're trying to find, cover up with your finger. So if you cover up the V, it's distance over time. Now take your finger, and since I'm looking for distance in this problem number 2, cover up the D. And what you're going to end up with is D equals velocity times time. See, if you cover up the D, how V and T are next to each other. So you simply now put in the numbers for that. Well, the number for velocity was 65 miles per hour. The time was 5 hours. And so the hours cancel out, and you're left with 325 miles. So let's come down to number 3 now. It says if a car averages 65 miles an hour, we're going to do the exact same thing we did. That 65 miles an hour is velocity. So I'll put down the velocity equals 65 miles per hour. How much time? Well, how much means I'm looking for time here. Well, so T is going to be equal to a question mark. Will it take to travel to Washington, D.C., which is 690 miles away? So I'm going to put in the distance, 690 miles. And once again, you can use that little triangle here of V equals D over T. But now I'm looking for time. If you take your finger and cover up the T, it says that T is not, sorry about that, T equals D over V. There we go. So now I simply put in those numbers. Distance is 690 miles. The velocity is 65 miles per hour. The miles are going to cancel out, and you're going to be left with 10.6. Come on, pen. Hours. Go to number 4. Number 4 says, what is acceleration? Well, that means they're looking for you to find A. I'm going to put a question mark next to A. Pay attention to those words like what? So what's the acceleration of a dragger that starts at rest? Well, pay close attention to words like rest and stop, because if it starts at rest, that means its initial velocity is 0. So I can put down that. And it accelerates to 120 miles per hour. Now, don't confuse 120 miles per hour with acceleration, because it's going from rest to 120 miles an hour, which is its speed. So its final speed is 120. And it says it does this in 4 seconds. Well, that means my time is 4 seconds. Now I got to figure out my acceleration. The formula we've used for acceleration, come on, Pin. Acceleration, the formula we use for acceleration is A equals delta V over delta T. And so let's go ahead and put that in. A equals change in velocity, which is final velocity minus initial velocity. And my change in time, let's put change in time down here. So I'm going to put in 120 minus 0 over, this is miles per hour, over a time of 4 seconds. And let me get this out of the way here. So my final acceleration is going to end up being 30. 12 divided by 4 is 3, and add the 0, miles per hour per second. If your acceleration is 30 miles per hour per second, what that means is every second you speed up 30 miles per hour. So after 1 second, you're going 30. After 2 seconds, you're going 60, and so forth. Look at number 5 here. That gets a little tricky, because it now says you decelerate at 30 miles per hour per second. So what I just gave you was, what I just gave you here was acceleration. Negative 30 is my acceleration, so I'm going to put in a negative 30 miles per hour per second. It says how much time? Well, how much? You got to watch out for those words there. T is what I'm looking for. Does it take to stop if it lands at 300 miles per hour? Well, that means its starting position, or starting position, but starting velocity is 300 miles per hour. But if you notice, I skipped over something very, very important, because it says how much time does it take to stop? Well, if it's going to stop, that means its final velocity must be 0. So let's come over here to this triangle again. If A equals V over T, and it wants to know how much time, I'm going to cover up the T with my finger, and now know that T equals change in velocity over, sorry, over change in acceleration. Actually, I'm just going to put down acceleration. Well, to get my change in velocity, it's final velocity. Well, the final velocity is 0 minus the initial velocity. The initial velocity was 300. So it gives me a negative 300 over a acceleration of negative 30. This is miles per hour per second. This is miles per hour. They cancel out, and you're left with 10 seconds. And guys, if you ever get a negative time, that means you did something wrong so far. We can't have negative time yet. Then finally, number 6. Number 6 is a little tricky, because if you start reading, it says if the Brainsmobile can accelerate from 0, well, 0 miles per hour would be my initial velocity. To 60 miles per hour, that'd be my final velocity. In 6 seconds, that's going to be my time. What will be its final speed? So I'm looking for final velocity. Uh-oh, wait a minute here. I thought I already had final velocity. Come on. Working. So what would be my final velocity after 5 seconds? Well, I'm looking for final velocity. And final velocity is equal to A times T. The thing is, though, I wasn't given A. Well, you can find out what A is. So watch what I'm going to do here. I'm going to do this in a different color. I also know that A is change in velocity over change in time. So let's plug all this stuff in now. My change in velocity was 60 minus 0. And it said that I could do that in 6 seconds. Then it says it wants to know how fast you'd be going after 5 seconds. So I'm going to put the 5 seconds in for this time. Well, if I take 60 divided by 6, I get 10. 10 times 5 gives you a 50 miles per hour. That's a little tricky because it's like doing 2 problems in one.